MS Ramaya University of Applied Sciences.
Hello students, let us discuss about surface roughness measurement. To measure surface roughness for a given specimen using contact probe method. Surface finish affects aesthetic, safety and assembly of products. Aesthetic reasons. Surfaces that are smooth and free of scratches and blemishes are more likely to give a favorable impression to the customer. Friction and wear depend on surface characteristics. Assembly of parts is affected by their surfaces. Roughness plays a vital role in the capillary action of brazing filler metal. Let us look at a typical metallic surface. It has a surface texture, altered layer and a substrate. Surface texture. The exterior of the part is a surface whose topography is anything but straight and smooth. In this highly magnified cross-section, the surface has roughness, waviness and flaws. Although not shown here, it also possesses a pattern and or direction resulting from the mechanical process that produced it. All of these geometric features are included in the term surface texture. Altered layer. Just below the surface is a layer of metal whose structure differs from that of the substrate. This is called the altered layer, and it is a manifestation of the actions that have been visited upon the surface during its creation and afterward. Manufacturing processes involve energy, usually in large amounts, which operates on the part against its surface. The altered layer may result from work hardening, that is mechanical energy, heating, that is thermal energy, chemical treatment, or even electrical energy. Substrate. The bulk of the part, referred to as the substrate, has a grain structure that depends on previous processing of the metal. Surface texture consists of the repetitive and or random deviations from the nominal surface of an object. It is defined by four features: roughness, waviness, lay and flaws. Roughness. Roughness refers to the small, finely spaced deviations from the nominal surface. It's determined by the material characteristics and the process that formed the surface. Waviness. Waviness is defined as the deviations of much larger spacings. They occur because of work deflection, vibration, heat treatment, and similar factors. Lay. Lay is the predominant direction of pattern of the surface texture. It is determined by the manufacturing method used to create the surface, usually from the action of a cutting tool. Flaws. Flaws are irregularities that occur occasionally on the surface. These include cracks, scratches, inclusions, and similar defects in the surface. Possible lays of a surface. Surface roughness is a measurable characteristic based on the roughness deviations on the surface. It is a contact type of measurement, also known as skid type of roughness measurement. Here, the specimen surface is placed under the tracing probe. The stylus has a diamond tip that is traced backwards on the test specimen. The stylus with the diamond traces the peaks and valleys on the surface. The mechanical fluctuations of diamond tip is converted into electrical signals and later filtered to capture the surface roughness. The most common roughness measuring parameter is RA, or arithmetic average roughness. It basically reflects the average height of roughness component irregularities from a mean line measured in micrometers. RA is defined as the average roughness value computed by taking the average of absolute deviations from the mean line. Higher the RA, higher will be surface roughness and vice versa. The symbol used to represent the surface texture shows information on the roughness value, both minimum and maximum. Specifies lay symbol, cutoff length, waviness and roughness spacing. This symbol is placed in the engineering drawing for specifying the surface texture requirements. Before getting started with the measurement of surface roughness, let us understand more about the prerequisites for roughness measurement. One has to have the following information beforehand. 1. Manufacturing process used to make the part or specimen. 2. Expected roughness value. 3. Cutoff and evaluation length as per ISO standard. 4. Type of units required, RA, RZ, RT, etc. 5. Lay direction. 6. Specified tolerance in the drawing. 7. Range of the measuring instrument. Roughness value depends on the manufacturing process adopted. Here we can see the typical expected RA value for different manufacturing processes. For example, milling operations will generally produce surfaces with a RA between 0.8 to 6.3 RA. This information is vital as the cutoff length and evaluation length depends on the expected RA. Now, let us understand cutoff and evaluation length. Cutoff length, lambda C, by sampling length is the length that is needed to differentiate wavelength of roughness from that waviness. Evaluation length is the part of the traversing length from where the values of the surface parameters are determined. Usually, evaluation length will be 5 times the cutoff length. Cutoff length and evaluation lengths must be input to roughness measurement tester based on the expected RA value as per well-defined standards. Here, one can see the defined sampling length or cutoff length and evaluation length for the corresponding expected RA value. For example, for a specimen that is milled, the expected RA ranges from 0.8 to 6.3 and corresponding sampling length is 2.5 mm and evaluation length is 12.5 mm as per JIS B0601 2001 and ISO. Surface roughness measurement can be measured for varieties of components that are used for different applications. The limitations of this type of measurement is, it is two-dimensional measurement. It is best suited for metallic specimens. Prior information about the expected RA for a given specimen is a must. Waviness can be part of roughness measurement if cutoff length is not respected.
Hi students, the next experiment is measurement of surface roughness using contact probe method. The aim of this experiment is to measure the surface roughness of the given specimen using the contact probe method. The apparatus required to conduct this experiment are the surface measurement tester. Now let us see the surface measurement tester. The surface measurement tester has a LCD screen on which you can see RA, RQ, RZ, the power button, the start and stop button, the page button for navigating between the menus. The next part of the surface roughness tester is the drive unit. The drive unit is attached to a probe or a detector probe which has a stylus. The stylus is of a retracting type. The diamond tip stylus will retract on the measured surface to get the RA or the roughness values. The calibration stand. This is plastic stand for calibration. Master for calibration. This is the master specimen used for calibrating the surface measurement tester. One can see RA of 2.94 micrometer, which is the standard roughness value of this specimen. The height gauge. We are using a height gauge to mount the drive unit of the surface measurement tester, and a V block. This is a magnetic V block used for holding the component. You can see the off situation of the knob. We can make it magnetic by turning this knob into the on position. Now we can mount the component. These are the components. This is a milled plate for which we are going to measure the surface roughness. Before starting the experiment, we have to calibrate the surface roughness measurement tester. So let us switch on the surface roughness measurement tester. So here is the power button. Now I will press the start button and see that the detector probe comes out from the tester. Now one can observe the detector probe coming out from the drive unit. This is the home screen. You can see RA, RQ, RZ. Now let us calibrate by entering into the home screen or the main menu. You can see the calibration option. So let us select the calibration option. Now the instrument is ready for calibration. Now let us use the stand for calibration. This is the master specimen or the reference specimen for which we know the surface roughness value. The surface roughness value RA is 2.94 micrometer. So I am going to place it on the stand. The next step is placing the instrument so that you can start calibrating. Now let us calibrate. I am using the start and stop button for calibration. Now you can see the display and the surface roughness being measured, and also the contact probe coming back or tracing back. Next, press the button, red button, which is used for updation of the current value. Now it is updated. Now the calibration process is completed. Now the instrument is ready for measuring the surface roughness. Now let us remove the drive unit from the instrument and mount to the height gauge. So I am removing the drive unit connector plug. I am using the align screw to mount the drive unit. This is an extension cord which connects the main unit and the drive unit. Now let us take the V block and mount the component. Now the component is mounted to the V block. Now let us adjust the drive unit and the component close to each other. One should know the component for which we are measuring the surface roughness. This is a component which is milled, and one can identify the lay pattern. You can see the lay pattern if you are coming closely, or one can feel the lay pattern by hand. The expected RA for this milled part lies between 0.8 to 6.3 micrometers. So before measuring the surface roughness, one should make sure the surface is free from dirt or oil or any other foreign particles. So clean the surface and then mount it on the V block, and then go for measuring the surface roughness. This on the LCD one can see RA, RQ, RZ. So these are the different types or different ways one can measure the surface roughness. I am choosing the RA. I have selected cutoff length lambda c to 2.5 mm, and the evaluation length is 5 times the lambda c. So my evaluation length will be 12.5 mm. My cutoff length or lambda c will be 2.5 mm. This lambda c and cutoff length depends upon the expected RA value. For our specimen, the expected RA value ranges from 0.8 micrometer to 6.3 micrometer. Now one can see an orange strip which indicates a no load condition. The measuring probe exerts a force of 0.75 micronewton on the surface for which measurements have to be taken. Now gently tap the probe on the metal surface, and you see the orange strip turning into blue one, which indicates a loading of the probe. Once the probe is in the loading condition, lock the height gauge and start measuring the surface roughness by pressing the start button. Now let us start the measurement by pressing the start button. You can see the pattern or the roughness pattern here on the LCD screen. Once the probe has reached the evaluation length, it will come back to the home position and the device will calculate the RA value. Now you can see the RA value 3.489 micrometer, RQ is 4.045, RZ is 15.231. Similarly, 16 varieties of surface roughness measurement units are available in this tester. So you can choose the appropriate measurement unit. RA is one of the commonly used measurement unit for measuring roughness value. Repeat the same experiment 3 times in the same position and get 3 RA values and take the average, and that will be the average roughness value for the given specimen. This completes the experiment measurement of roughness value using contact probe method. Thank you.
At MSR UAS, we spark your imagination unlike any other.